Hello all. Today we are discussing about addressing modes. Before that, what is addressing mode? What is the importance of addressing mode? So the addressing mode is nothing but the different ways of specifying an operand in an instruction is called as an addressing mode. So we can represent the operands in the instruction in different ways. Okay, so we have 12 types of addressing modes, and these are the different types of addressing modes. So we will discuss each one in detail. Coming to the implied addressing mode. Implied addressing mode is also called as implicit addressing mode. Okay, let us consider the basic instruction type. How you represent the basic instruction by using opcode and operand. Opcode is nothing but whatever the operation you want to perform, simply have to mention that opcode like add, null, like that. And coming to operand, you can represent the operand in two ways. First one is main memory location and second one is register location. Okay, coming to implied addressing mode, in implied addressing mode, the way of representing an operand in an instruction is in an implicit manner, nothing but no need to represent the operand explicitly. Okay, for example, what is the important, what is the example for that is complement accumulator. Before that, we have an idea about what is accumulator. So accumulator is a storage area, okay, which may be main memory address location or register address location. The main purpose is it will store the intermediate results of the arithmetic and logical operations. That is the main functionality of accumulator, and accumulator consists of default data. Okay, for example, you want to perform addition operation. If you write add, so no need to represent the operands. Okay, for example, add 10, so 10 is immediately added to the accumulator. So that is comes under implied addressing mode. It is also called as implicit addressing mode. Moving to the second addressing mode is stack addressing mode. So in stack addressing mode, so we are already know that stack follows the LIFO order, last in first out order. When you mentioned the opcode is add, what happened is initially the two operands values or came out from the stack, nothing but pop out of the top of the stack. Then addition operation is performed. After that, the result will be stored into the top of the stack. This is the main purpose of the stack addressing mode. Okay, I'm repeating, in stack addressing mode, what happened is when you mention the opcode add, it will come out from the two operands or immediately come out from the stack. The operation is performed and result is stored into the top of the stack. This is about the stack addressing mode. Moving to the immediate addressing mode, this is also called as an explicit addressing mode. If you observe that, so immediate addressing mode, nothing but if you observe that opcode and this is the operand. So here we are representing the operand is by representing the value of that operand value. Normally, how you represent the operand, nothing but you may mention the some memory address location or register location like that. But coming to explicit addressing mode or immediate addressing mode, if you observe here add 10, so when you mention add 10, so the immediately it will be incremented in the accumulator value by using the 10. So that is one way. And move r hash 20, so what happened is this 20 is immediately it is a constant value, so the register r is initialized by the initialized with register value is 20. So this is an example of explicit or immediate addressing mode. And moving to the next one, direct addressing mode. So this is comes under direct memory addressing mode. So here we have to access the effective address. Effective address is nothing but the direct address of the operand value. If you observe the instruction type here, opcode, and this is the operand. When you mention the operand by using some alphabets like that, so you can easily understand, so it is belongs to the memory address location, not the register. Okay, that's it. Okay, here I want to access the some operand from the memory, so no references are needed, directly you can access the operand value from the memory. This is called direct addressing mode. Okay, if you want to represent the direct addressing mode with some example, here I want to perform addition operation. Okay, so what is happened here, AC is nothing but accumulator. You are adding some value to the accumulator. So simply you are representing that some x value within the brackets. It indicates that no reference is needed. So you can directly access the value from the memory by using direct addressing mode. Next, moving to the indirect addressing mode. In indirect addressing mode, if you want to access the address operand from the memory, for that you need one reference. For example, how to understand this diagram. Okay, if you observe that A is the memory location, here we are directly connected to the some ea is nothing but some other memory location. This memory location consists of exact memory location of the operand. Try to understand one point here. So this is the location address, this is the operand location. So initially it is connected to the some other memory location. Some other memory location consists of an effective address of the operand value. So nothing but one reference is needed. If you observe the example here, what AC arrows and AC plus, if you observe that two square brackets mentioned. Okay, while reading this statement or instruction, you can easily understand. So okay, this comes under the indirect addressing mode. Nothing but we need some other memory location. It will store the exact address location of the operand. That's it. Next one, register direct addressing mode. In register direct addressing mode, no references are needed. You can directly access the operand from the register set. Here we are storing the data in the register. We can store the data in memory, main memory, and we can also store the data in registers also. Register was a storage area, so it is used to store the data, and you can access the data from the register. It will be fast compared to main memory. Okay, register direct addressing mode. What is the example for that? Here also we are using accumulator. Why? Because we are performing addition operation when you mentioned add or, so it will be incremented the values that are stored in the accumulator. Why? Because initially accumulator stores some data. The main motto is to store the arithmetic and logical intermediate data, right? Next, moving to the register indirect addressing mode. In register indirect addressing mode, it is similar to the indirect addressing mode of the memory. At the time also we need one memory, one reference is needed to retrieve the exact operand value from the memory. So what happen is, initially we are representing the register in the address part of the instruction. This is an opcode is an nothing but what you which type of operation you have to perform, definitely have to mention opcode for that. And coming to R, this is comes under an address part of the instruction. In address part you mentioned that the register. Okay, so initially the register consists of exact address location of the operand. So you can store the operand in memory or register, no problem, but here we are using memory to that. When you mentioned operand which is resided in the memory, so definitely operand consists of some address location. So this address location is stored into the EA. So EA is a reference to access the exact operand memory location. So this is about indirect addressing mode. Next one is relative addressing mode. So we are already know that how to access the data in indirect direct manner. Coming to relative addressing mode, so here we are nothing but we know that a new terminology like effective address. Effective address is nothing but a direct address. Okay, to retrieve the effective address of the operand, for that you have to perform combining of some content of PC with the address part of the instruction. If you observe that PC is a register, PC is nothing but program counter. The functionality is it consists of the address of the next instruction execution. For example, the next instruction is going to be executed. What the PC will do that it will store the particular address of the next instruction. Okay, here we are adding the address part of the instruction and some content of the PC, then only we get some effective address. Once you get the effective address, you can easily access the operand value which is resided in the memory. So this is a relative addressing mode. Next, index addressing mode. In index register, so we are if you observe that here in the instruction we added some more content here, opcode, and this is the address part. Along with that we are added some index register. So initially the index register consists of some memory, some data. So if you want to access the effective address of the operand, for that what you have to do, you have to add index register content which is reside in the register set, and the address part of the instruction. If you combine both, then only you get the operand value which is reside in the memory. You can directly access that operand. Fine. Next, base register, which is very similar to the index register. So in index, what we perform index register, nothing but we mention some index register. We are adding some content of the index register to the data part of the address part of the instruction. Here also same, base register. In base register, we are adding some register set, the content of the base register with address part of the instruction. After combining both, we get the effective address. Okay. Once you know the effective address, you can easily retrieve the operand value from the memory. Fine. Next, auto increment and auto decrement addressing modes. These are the two increment and decrement addressing modes, which plays a crucial role. But now, how you know that? What is the difference between normal address in the instruction part of the instruction? Nothing but you have a doubt here. What is, if you observe that opcode, and I mentioned here or auto. When you mention or auto, so it represents that, so the address location is automatically incremented. But how it will be incremented? For that you have to fix the step size for that. Okay, for example, if you observe this example, here initially I mentioned some address location of the memory in the register set is 3300. Okay, once I found it that a location, address location in the memory, then easily I can retrieve the data from the corresponding memory location. And after that what will happen, you are already fixed the step size, right? So when you fix the step size, it will be automatically incremented. If you observe the address locations here is 3300, 3298 and 3302. Nothing but here step size is 2. Okay, once the data is retrieved from the corresponding address location, then the control, then the R auto is immediately point out in the next location, next address location based on the step size. Next, coming to auto decrement addressing mode, this is also same. In previous addressing mode we discussed about how to perform auto increment by using the step size. Here also we are using we have to fix the step size. Once the step size is fixed, here what we have to do in this example. So we want to retrieve the data from the address location is 3302. Okay, once the data is retrieved, immediately it will be decremented. So this is about the addressing modes. Nearly we have yes, we have 12 different types of addressing modes. Thank you.